We're going to talk a little bit about what you can expect tomorrow, rain or shine, and especially if there's clouds, we're going to talk a little bit about how you can still enjoy the eclipse in that case too. Before we get started, I want to introduce you to the NOVA team behind the camera. So very quickly, I want to introduce Tara, our producer of this live stream. And we've got Julia Court. She is one of the co-executive producers of NOVA. She's like in charge of the whole program. And we've got Joni running the camera. I'm introducing them because they are going to be monitoring comments for me and doing their best job to get any questions that you might have to me to pass on to Nikki, our expert. So if you have a question for a NASA scientist, now is the time to ask it, and we will do our best to get to it. If we can't get to it, we are going to be doing more live broadcasting tomorrow, so we will hopefully get to it by then. Nikki, please come on over here.
Hi.
Thank you for making some time for us today.
You are welcome.
So, head of science at NASA, that is a pretty amazing title. Sounds pretty high up. Tell us a little bit about what you do.
So for me, it is the best job on and off the planet because I get to oversee all of NASA science. And so we have 5 science divisions that we have. So we have planetary science, responsible for the moon, which is playing a big role tomorrow. Heliophysics, in charge of the sun, you know, make it a big deal tomorrow. We have earth science, which of course is where we're going to stand to watch the eclipse tomorrow. And then we have astrophysics, celebrating our all-stars. And we have biological and physical sciences, who are going to be doing all kinds of experiments using radiation from the sun. So it's an exciting job.
So I think most people expect the solar eclipse to be an amazing spectacle. But tell me about science. Is science actually getting done during this eclipse? And why is NASA interested?
Oh, yeah, we have so much science going on. We have all kinds of different experiments, either looking directly at the sun during the eclipse and being able to do some really cool sort of high precision measurements of sunspots and active regions. We're also looking down during an eclipse. It's the only time you can really look terribly close to the sun, and so we can see the chromosphere and the layers in the corona. And we also, not just looking at the sun, we're also going to be studying our own Earth's atmosphere, which will change quite dramatically during the eclipse. So lots and lots of science going on.
I'm going to get more.
Okay.
Every time you're going to change it a little bit, but first, I mean, we see it. NASA's got a stage there. What is going on here? What is happening in Kerrville?
So Kerrville is a very special location because not only are they in the path of totality tomorrow, but they were also in the path for the annular eclipse that we all celebrated in October of last year. I'm going to
stop you right there. What's an annular eclipse?
An annular eclipse, great question. So a total solar eclipse is when the moon is at its sort of closest in its orbit. It's not a totally circular orbit. So when it's at its closest, it actually appears to be the same size in the sky as the sun, which is why it can block out all the light of the sun and we see that beautiful corona. During an annular eclipse, it's a little bit further away, and so it's not quite big enough in the plane of the sky. And so when it crosses in front of the sun, and you get like a ring of fire around where the moon's causing that shadow. So that was what we had in October. That's actually a very rare type of eclipse, but this is the crossing point. Kerrville is the crossing point for those 2 eclipses. So it's amazing, less than 6 months apart, and Kerrville is celebrating 2 eclipses. So that's why we're here. And then tomorrow there's a music festival here. We'll be broadcasting live. We're one of the 2 hubs for the NASA broadcast. It starts at noon Central Time, goes throughout the path of totality. So we're here, and we're also in Cleveland, Ohio, at the Glenn Research Center. So a lot of activity here. There'll be some solar telescopes set up here, and lots of activities, and lots of great stuff for everyone to do that comes down and joins us here in Louise Hayes Park.
So what will you be doing? Where will you be for the eclipse?
For the eclipse, I will actually be broadcasting. So I do get to narrate totality tomorrow, which is very big deal. I know, very excited. So hopefully you will get to see me get really excited on the NASA broadcast about how beautiful that corona is.
So let's talk a little bit about the weather. I know a number of people made plans to come to Texas for the weather. Tell us a little bit about that. When NASA planned to be here, what was the weather supposed to be?
I mean, we were expecting clear skies. Texas had actually the highest probability of being clear for the eclipse, which is one of the reasons that we have several locations that we're broadcasting from. We have a big presence in Dallas, some folks in Austin and San Antonio as well. it looked like it was going to be really good. But we have mixed forecast. I mean, today, as you can see, it's lovely and sunny. It was supposed to be, completely cloudy here. Yesterday, they forecast clouds, and we had a really beautiful sunny afternoon. I'm ever hopeful that we will have a nice clear day. And even if it's hazy clouds, quite often when totality occurs, you get a drop in the temperature and those clouds clear. And that's what actually happened where I was in 2017. It was totally cloudy. I was really, really depressed. And then when totality hit, the clouds parted and it was like a frame around the eclipse. And so, that's what I think we're going to get tomorrow.
That's amazing. Beautiful. Can you say a bit more about that? How does temperature dropping make clouds clear?
It's just an atmospheric effect. So you don't have that many clouds at night. It's fairly rare, and it's just that they dissipate. They will come back, and again, that's actually what happened to me in 2017. It cleared, and then right after the eclipse, the clouds came back. So the temperature can very much, we hope, even give us clear for that total solar eclipse period.
So praying for sun. If it is sunny, let's talk about safety for a second.
Yes.
I think most people have heard by now, don't look directly at the sun. Why? What would happen?
You will actually burn your retina. You will cause permanent damage if you stare at the sun for a long, for the duration. It would be extremely bad. So, we recommend, obviously, eclipse glasses are really great. Sunglasses are not eclipse glasses. And I've had several questions this weekend about, these are really Polaroid, high strength, sunglasses. Are they good enough? No, they're not. I even had somebody ask me if they put sunscreen on the outside of their sunglasses. Would that be enough? No, it isn't. You will really damage your eyes. So eclipse glasses, you can also get like a pinhole projector, like something with a very tiny hole in it. And you sort of put it, get the sun in the pinhole and put it down on the ground, and you can actually image the eclipse as it's happening. You can even kind of make your fingers in sort of a waffle pattern and make a very small hole. Do the same thing with that, and you'll be able to see it on the floor. Wonderful props coming in.
We have some nice Nova branded glasses here. And the important thing with the glasses is to make sure they're the ISO 12312-2.
That's right. That's right.
Surprisingly easy to remember.
And you can also on the NASA website, if you go to go.nasa.gov/eclipse 2024, you can find about a lot of information about making sure that your glasses are safe. But as soon as you want to start looking at the sun, when the moon starts to cross over, those glasses need to go on, and they need to go on literally until you can't see anything anymore. And because everyone keeps asking me, how will I know when to take the glasses off? When you can see nothing at all, take the glasses off.
Okay. How will you know when to put the glasses back on?
So you kind of have to think about that. So you'll see the Bailey's beads and the diamond ring that appear. They're the sort of the last things that you see right before totality. As the moon moves away from totality, they will start to appear again. Once you start to see those bright lights, that's when you need to put those glasses back on. And if you want to stay and enjoy the sort of the end of the eclipse and watch as the moon moves right the way across and the sun comes back, those glasses need to be on. And if you're somewhere where it's only a partial solar eclipse, all 48 contiguous states in the US will see some form of this eclipse, which is amazing. If you're not on the path of totality, those glasses are on all the time.
And you can test out the glasses today before the eclipse even starts. You shouldn't see anything unless you look right at the sun.
Yeah.
Now you had mentioned if you looked at the sun for the duration without glasses, it would damage. It's really if you look at the sun.
If you look at the sun, period.
Don't look at the sun.
Do not look at the sun. And I mean, if you do, you know how you always get that bright spot? Yeah, that's one of your pixels that's usually temporarily damaged as long as you don't look at it for very long. But yeah, you really don't want to look at it at all. No. And actually, the other thing is if you have a pinhole projector that you're using, that needs to be projected down with the sun behind you. Do not look through that little hole and think your eyes are protected. That's actually even worse. You're focusing.
So that's where you take an index card just like this.
Yes.
Poke a hole in it, then put it down.
Yep.
Not up.
That's right. That's right.
Okay. So if it is cloudy, sometimes, it's cloudy. You can kind of see the sun through the clouds. Does it look at the sun that way?
Nope.
Don't look at the sun at all.
Nope.
Just don't do it.
Just don't do it. Just don't do it.
Once
again, if you can see something through those glasses need to be on.
So if you look up at the sky with the glasses on, don't see anything, it's safe to take them off.
It would be.
It would be. Okay. So that's how you know. That's your test. Let's see. So here, if it's cloudy, what will the experience be like for those who are experiencing it?
Yeah, so it's still an amazing experience. And I'm still going to go for, we're going to clear for the eclipse,
Yes.
but that's because I'm ever hopeful. But there are other things that you experience. So one thing is you'll actually see the shadow, the moon shadow kind of racing towards you. So, you know, you will see that. And it really is.
Even if it's cloudy.
Oh, yes.
Oh,
yes,
wow.
because it's going dark. So, I mean, even though the sun's disappearing above the clouds, it will still go darker. And you'll see the shadow kind of racing towards you. And then you sort of become like engulfed in the shadow. And so even if you can't see the eclipse itself, you'll experience it in other ways. Often we hear like owls will start hooting. So like nocturnal animals and birds will come out because they think it's night. And particularly here, you know, we've got over 4 minutes of totality, and that is long enough for these things to actually happen. And we get a lot of nocturnal animals that will come out, and the daytime animals will kind of quieten down because they think it's nighttime. So there's lots of different things. It's very sort of, it's almost like a hushed feeling, and you know that you'll hear sounds of the eclipse. And you know, we have one of our citizen science programs is actually, they want people to record the sounds of the eclipse, and then we're going to put them all together. So there's a lot to actually experience, even if you can't see totality.
And I know we have some audience questions. I want to get to those in just a second. My last question is, you said that NASA's in a couple of places. If it's cloudy, it might not be broadcasting totality. My understanding is you've got a number of other locations set up.
We do. Yeah, we have 13 locations, Kerrville being the first, all the way up through Maine. And we will be broadcasting from each one of those. And we'll just be running the feed from here, but that's where we'll be broadcasting from.
Excellent. So NASA will be live broadcasting the eclipse because they are everywhere in the path.
We are everywhere in the path, yes.
And you can watch that at plus.nasa.gov. And we'll also drop that in the comments or the chat.
Yes.
We have some audience questions.
Great.
What are they?
Just a second.
How is it that the moon came to be exactly the same size as the sun in the sky? That's a great question.
It is just geometry, and so it's actually lucky. And you know, eventually the moon will go further away. The orbit is actually getting bigger, very, very slightly, but eventually there will be no total solar eclipse. It will be almost like an annular eclipse all the time.
And it's just a coincidence, right?
It is one of those amazing coincidences where at just this point the moon is exactly the same distance in the plane of the sky. The angular distance is the same.
Cosmic coincidence.
Cosmic coincidence.
Wow. Amazing time to be alive.
I have seen one total solar eclipse only. I'm always the one that normally stays behind and broadcasts and talks about it. So I'm very excited to actually be here. So 2017 was my first one. This will be my second.
All right. And do we have another question?
Someone asked what can you see during the eclipse? Someone says, can you see stars?
Oh, great question. Great question. What can you see during an eclipse? So I'm a solar scientist, so unashamedly, I just stare at the corona. So that's a hazy atmosphere, looks like a crown that you will see, and it's actually amazing. The moment totality hits, you will see that
and
corona.
The corona is what
So
exactly?
that is the atmosphere of the sun. So just like the Earth has an atmosphere, the sun has an atmosphere too. Because the sunlight is so bright, you really can't see it. But if you think about, even if you take a bright light bulb and you put a sort of cardboard disc over the bright light, you'll actually see a halo around there. That's essentially what you're seeing with the corona. So once you block out the light of the sun, you'll see that amazing corona. The other thing you will see is kind of the daytime night sky, if you see what I mean. So if you suddenly turn it off, you will see planets. I think we can see 6 planets, 6 or 7 planets tomorrow. There is a comet. It is very, very faint, and I know everybody wants to know if you can see the Devil's Comet tomorrow. I am told if you know exactly where to look, you may be able to see it, but it's going to be very faint, particularly against the corona. But you'll see planets, you'll see stars, not as many as you would see if it was true night, because it doesn't go quite as dark as night does. But you will see suddenly, it's like the sky turns on. It's really cool.
Sounds amazing. I've never seen one, so I'm really excited. It sounds amazing. So another audience question is, when will we no longer be? You said we're at a specific point in, I guess, the solar system's history that the eclipses happen on Earth. When will they stop happening?
It's going to be a while. Don't worry.
It'll
You've got
be a while.
plenty more chances to actually see an eclipse. Yes.
I think our prior Nova film on this covered it. I think it was a few hundred million years.
Yes. So, so you got plenty of time.
You got some time.
Yeah.
Some folks are asking how far north.
So
how far? Sorry, I'll just repeat that.
Yeah,
so how far north can people see the eclipse?
Maine is the furthest north you can see it in the US, but it does cross into Canada, and so it is going, I believe, over Niagara Falls, which would be a great place to see it. So it starts in Mexico, and it exits in Canada. But for the US, Maine is the furthest north, and I understand from some friends that are up in Maine that they just got a big snowfall, so that's going to be a very unusual thing to see the eclipse standing in like feet of snow. So we're looking forward to seeing the images from them.
Before there was NASA able to predict exactly where the eclipse would be and when and how were people able to observe and predict eclipses in the past?
Just literally by charting the movements of the planets and the movements of the moon, and you know, the reason we don't see one every month, which is usually a question I get, is because the moon's orbit is tilted, and so you know it doesn't do what we need it to do until it really sits down in that sort of straight line between the Earth and the Sun. So they really just charted how the moon's orbit was changing and could actually predict that we would see a total solar eclipse. But I have to say, the thing that always makes me go wow is, can you imagine if you didn't know what was happening? You know, like the first time a total solar eclipse happened, and you know, if you go down to like Chaco Canyon, you can see these cave drawings that are clearly an eclipse. There's no question, because they've drawn like features in the corona. But imagine if the sun just disappeared and you didn't know it was going to come back. You know, and there were all sorts of myths and legends of it was a dragon eating the sun. And I mean, just if you didn't know it was going to come back, that would be terrifying.
Yeah. And if you're interested in learning more about that, Nova's documentary film Great American Eclipse is streaming on the PBS website, the PBS app, and on YouTube right now. So we go into the history of some indigenous peoples' histories with eclipses, as well as even going back all the way to the ancient Babylonians. So right now we are taking questions from the audience with NASA head of science, Nikki Fox. We have a time for taking a few more if there are any more.
Can you talk about the corona and what is?
So we have a question on, why does the weather change when you have an eclipse?
So that's actually something we're studying. I'm going to say we have science experiments going that are looking actually. There's the temperature and various things about that together in a database, and we'll continue to see why the weather changes. And it is a slight. It's not going to be a dramatic change like the eclipse happens and suddenly you will feel the temperature drops by about 10 degrees though. So it is you will feel it. So not only will you get engulfed in that shadow, but you will feel a 10-degree change. And so that's what sort of just changes the atmospheric conditions. Also, our atmosphere itself, our ionosphere, so that's sort of the charged part of our atmosphere. It's charged because photons from the solar radiation comes in and basically knocks electrons out of our molecules in the atmosphere, and it becomes charged, and that's our daytime ionosphere. So it's pretty thick, and when we get to nighttime, they kind of recombine, the electrons recombine, it becomes neutral again, and the ionosphere becomes very thin. Now, normally that's a pretty slow transition because we're used to going from day to night back to day. This is going to be off goes the sun, instant night. And so we have some great experiments. We have 3 sounding rockets that are going to fly. One's going to go 45 minutes before totality, one will go at totality, and the last one will go 45 minutes after, to actually allow us to study how that atmosphere changes. And the reason we want to use sounding rockets, we can get them to the right altitude that we need to be at the right time. We have many spacecraft that can study it, but if they're not in the right place at the right time, they're not going to be able to get that data. So that's why we have some sounding rockets going up to be able to answer all these questions about what happens in our atmosphere, and then, you know, what changes does that drive around us.
I have a question. This is my question. I keep on hearing about these sounding rockets. I don't actually know what a sounding rocket means.
Great. It's basically a rocket that does not go into orbit. So it will go up. For us, it's going to go up to about 300 feet in the sky. It will go up, and it will take 300 miles, 300 feet, 300 miles up into the ionosphere, and then it will just do an arc, and they come back down. So but it's a great way to do science, because you sort of get the trajectory, so it's arcing and flying through the phenomena, and then it comes back down.
Very cool. Do we have any other questions from the audience? Yes.
Oh, about the corona, like why is NASA interested in it?
Why is NASA interested in the corona of the sun?
So we're all really interested in the corona, because that literally is where the solar wind is born. And you're going to ask me what the solar wind is. So the corona is basically the atmosphere of the sun. Sorry, and in that region that you will see tomorrow during totality, it's actually 300 times hotter than the visible surface of the sun, and the material there becomes very, very energized. It then breaks away from kind of the pull of that giant magnetic star and moves radially away from the sun. It bathes all of the planets and actually carves out a protective bubble for us as we go around the Milky Way. What that also carries with it is that you sometimes hear about flares and active regions and coronal mass ejections or solar storms. Sometimes big regions, some of the regions that we're actually going to be studying tomorrow, can get very unstable, and they can sort of explode, and they can send billions of tons of this coronal material traveling at millions of miles an hour directly towards our planet. When that happens, we will feel an impact. We often see beautiful aurora, but we can have power grid issues, satellite issues, GPS issues. So it's very important for us to study and understand the corona, so we can understand our relationship with the sun. And also, our sun is an average star. So there's many other stars like it. So what we learn about our star means we can actually apply it to other stars. And so as we move, to look for planets that could sustain life in other galaxies, we need to understand that relationship. Why is our planet sustaining life? What is that relationship with that star? And then how do we apply that to other stars and exoplanets and other galaxies?
So studying the solar eclipse can actually help give us some clues to understanding how life elsewhere in the universe.
Absolutely.
Wow.
Absolutely.
Amazing. And I'll just add, if you want to nerd out more on solar science, we're going to do a deep dive in our live stream tomorrow at 12 Eastern, 11 Central. And you can check out Great American Eclipse, NOVA's 1-hour documentary film on our website and the PBS app. Do we have, I think we have time for a couple more questions from our audience.
Got
one last one, I'm being told.
What sets this eclipse apart from the 2017 eclipse?
Oh, I love the question. Right.
Then I'm going to combine it with another question I just got from our remote team. What sets this apart from our from the 2017 eclipse, and why is the path different every time? So the path is just different every time, because it's literally the mechanics of where the moon and the earth are, which part of the earth is facing the sun at what time, and how our earth axis is tilting. So it looks different in the fall to how it would in the spring, because our axis is different. And so that's why the path changes all the time. But I love the question, why is this one different to 2017? So the sun, not only, amazing star as it is, has an 11-year solar cycle. So just like we have a weather cycle here, or, like a winter to winter cycle, they have a maximum and a minimum. At solar minimum, the sun is pretty quiet, not too much activity going on the sun. At solar maximum, all those active regions, all those flares, all this really exciting stuff going on. We are now on the path up to solar maximum. So somewhere late this year, mid next year, it's difficult to predict exactly when it will be. That will be solar maximum. So the corona will look very different to how it did in 2017. 2017, it was a pretty quiet, pretty uniform corona. This one
one is going to be spiky and look very, very different. And if my dreams come true, a big event on the sun will go off during totality and I will actually see a coronal mass ejection. It has happened before. And so that's what I'm hoping for clear skies and a coronal mass
clouds are going to
ejection.
part.
That's right.
And there'll be a solar flare.
That's right. And then I will be happy. I will check off many bucket list items at that point.
And I just got one last question. It's so good. I've got to ask it. And then we do have to wrap up,
Okay.
which is, will the solar eclipse be visible from the International Space Station?
Actually, it's visible, but in a slightly different way. But the ISS is moving pretty fast. But yes, the astronauts will be able to see it. Obviously, there are not very many windows that look out that way because you don't want to normally be looking at the sun. But what they will really experience is they will look down and they will see the shadow of the moon passing across the Earth. So it's not so much that
will
they'll
they be getting
see
pictures of that for us?
Oh yes,
you're going to post them.
Absolutely, we'll get loads of pictures from the ISS. Yes, but that's a big thing, and I think they will actually go through it a couple of times. So you know, as we have planes that are going to be chasing the eclipse and trying to see totality for longer by kind of moving with the shadow, they will also be coming around and imaging the shadow a couple of times. So it's going to be really exciting.
Well, next time you build an International Space Station, maybe put some windows so that they can see the solar.
Yes.
All right. Thank you so much.
Thank
Again,
you.
This was Nikki Fox, head of science at NASA, and she is going to be right here narrating the solar eclipse tomorrow. NASA's live stream will start at 12 p.m. Eastern time, and they'll be broadcasting from across the country. So you will be able to see some eclipse action from NASA. NOVA is going to be live streaming again tomorrow at 12. No, you go at 1 p.m. Eastern.
We go at 1 p.m.
I'm sorry.
Yeah,
NASA goes at 1 p.m. Eastern.
Yeah.
We're sorry, time zones. I always get you. We'll be going at 12 p.m. Eastern, 11 a.m. Central, and doing a deeper dive into the science of the sun.
Wonderful.
And so we will see you then. Thank you so much.
Question. What's the NOVA team going to be doing from between now and tomorrow?